All right, we are going to call this 8-4 day 2. I'm going to work through two slightly tougher expressions to simplify with trig identities, numbers 5 and 6. I can't remember in the first day. I might have done number 5. If I'm doing it again, I apologize for that. I don't mean to, but it's not a bad problem. I'm fairly certain I haven't done it, but we're going to do it. Either way. I hope by now, with a little bit of practice, that you're seeing that and recognize that the place to start on this example in number 5 is on the bottom. 1 minus cosine squared would use a Pythagorean identity, and it's just calling out to us to simplify it. So I'm not going to do anything to the top yet. Leave that as sine times cosine, and that's huge as you're doing this. Every step, just one thing at a time. Okay? We have it in our list of identities that 1 minus cosine squared, that's sine squared. Okay, 1 minus cosine squared equals sine squared. Now what I can do is take the bottom, I should say sine of x, and I could split that up as sine squared is sine of x times sine of x. When I do that, a pair of those cancel. And then I am just left with cosine over sine. Tempting to leave it like that and think that we fully simplified, but we haven't. Cosine over sine involves another trig identity, one based off of a quotient. That quotient of trig functions is equal to cotangent. And there we are. That's our ending point. That's fully simplified. We took number 5 and started with sine of x times cosine of x divided by 1 minus cosine squared of x. And we just verified that that is actually equal to cotangent of x. Oh, let's take a look at 6. This one takes even a few more steps than that one. This one might be tough to see right here. It's actually kind of similar to number 4 in the sense that there's a relationship that tangent has with two angles that are complementary. We saw that sine and cosine, if we have two angles that add up to 90, one of those angles' sine values is the other's cosine value. We didn't talk about this in day 1, but the same is true for tangent and cotangent. Okay, if you were to draw just kind of an arbitrary right triangle, label the sides A, B, C, X, Y, R, or whatever, you could verify this pretty easily. All it would take is one little sketch with a right triangle. In fact, I will do it. I will prove to you in one little diagram that this is true. X, Y, and R. Okay, sigma and alpha. Alpha and theta, because this is a right triangle, we know those two add up to 90 degrees. Okay, and the cotangent ratio for alpha would be adjacent over opposite. That would be x over y. And the tangent ratio for theta would be opposite over adjacent, and that would be x over y. Okay? Really basic example right there. Theta and alpha, again, this is totally arbitrary. There's no numbers, so it applies for all cases. Theta and alpha are complementary. Alpha's cotangent value is the same as tangent's, same as theta's tangent value. Okay? So that would be my first step here, is to leave the top as sine of x times cotangent of x. I mean, one of the pain of verifying trig identities is you feel like you're writing out so much stuff and there's so many things that you're just rewriting, but it's worth noting that's really, really important, because these we should be doing one step at a time. Next step might be a little bit hard to, well, first of all, it's tempting to cancel those cotangents. Don't do that because we're adding cosine of x as well to the top. The top involves addition. Those cotangents don't cancel. Instead, what I would do on the top is I would take cotangent, write that out as cosine over sine plus cosine, and again, all of that is over 2 times the cotangent. Well, what good will that do? It'll actually cancel out those sine of x's, and will leave us on the top with cosine of x plus cosine of x over 2 times the cotangent of x. Now watch what happens here. Look at the top. What is cosine of x plus cosine of x? Well, that would be 2 times cosine of x over 2 cotangent of x. This is a case where I simply can cancel the 2's. There's no addition in there, it's all multiplication. And that leaves me with cosine of x and cotangent. This one's getting a little bit long, but we're getting close. We're getting really close. Tempting to say that we're done there, but something that we should check is what if we take cotangent and write it as cosine over sine? Kind of leaves us with a goofy looking expression, one that certainly isn't simplified. But instead of dividing by that fraction on the bottom, let's multiply by its reciprocal. So instead, multiply by sine over cosine. And there, we'll see that the cosines cancel. And holy smokes, we can simplify that expression all the way down to just sine of x. Okay, now that took, let's count them. 1, 2, 3, 4, 5, 6, 7, 8 steps. But that's pretty remarkable when you look back up here and see what we started with. Sine of x times cotangent of x plus cosine of x over 2 times the tangent of 90 minus x. We have verified that that entire expression is equal to sine of x. Okay? Not bad. Not a bad one to look at. 8 steps we're seeing here with verifying trig identities. That's probably close to the limit of how many steps that we could see. It's, again, when you go one step at a time, it's nice that you can communicate from one problem to the next as to how many steps it was. First one we did in number 5, that was a 4-step identity. And this one took 8. So it was twice as many steps. That's probably the toughest one that we've seen so far. So if you felt fairly comfortable with that one, you're in good shape. All right? We'll call it quits there. Again, this was 8-4, day 2. Just takes practice. These identities can be tricky. They take lots of practice. We need to see lots of them. Very important that you put a lot of time into these homework assignments. All right? If you have any questions on those assignments, please don't hesitate to ask when we see each other in class.